Welcome to our exploration of the biomechanics of human skeletal articulations. Today, we'll dive into how joints are categorized, what makes them stable, and the roles of different types of cartilage. Understanding joint biomechanics is essential for anyone interested in movement science, physical therapy, or sports medicine. We'll start by defining what a joint is and why its stability is crucial for everyday activities from walking to lifting. By the end of this video, you'll have a clearer picture of how our joints work together to support movement and resist injury. Let's begin by looking at the basic structure and function of human joints. Joints can be categorized in several ways, but two main criteria are structure and movement capabilities. Structurally, joints are classified as fibrous, cartilaginous, or synovial, each with unique characteristics. Functionally, joints are described by their range of motion. Some allow a lot of movement, while others are more restrictive. For example, the shoulder joint is highly mobile, whereas the sutures in the skull are immobile. This classification helps us understand why certain joints are more prone to injury or wear and tear. Next, we'll discuss the importance of articular cartilage and fibrocartilage in joint health. Articular cartilage and fibrocartilage play vital roles in joint function. Articular cartilage covers the ends of bones and synovial joints, reducing friction and absorbing shock during movement. Fibrocartilage, found in structures like the meniscus of the knee, provides additional cushioning and stability. These tissues help protect bones from wear and tear, allowing for smooth and pain-free motion. Without healthy cartilage, joints would be more susceptible to damage and degeneration. Now let's move on to the concept of joint stability and why it matters. Joint stability refers to the ability of a joint to resist abnormal displacement of the articulating bones. In other words, a stable joint keeps the bones in proper alignment, preventing dislocation or excessive movement. This stability is crucial for safe and efficient movement, especially during activities that place high demands on the joints. Factors such as the shape of the joint surfaces, the strength of surrounding ligaments and muscles, and the absence of fatigue all contribute to joint stability. Let's take a closer look at how the shape of bone surfaces affects stability. Shapes of articulating bone surfaces play a significant role in joint stability. When a joint is in a close back position, the contact between the bone surfaces is maximized, making the joint more stable. For example, the hip joint with its deep socket is highly stable in this position. In contrast, a loose back position has less contact and therefore less stability, as seen in the shoulder joint. Understanding these differences helps explain why some joints are more prone to dislocation than others. Next, we'll look at some common types of joints and their mechanical properties. There are several types of joints in the human body, each with unique shapes and movement capabilities. Ball and socket joints like the hip and shoulder allow for a wide range of motion. Hinge joints such as the elbow and knee permit movement in one plane. Saddle joints found in the thumb offer both stability and flexibility. These different joint types are designed to balance mobility and stability according to the demands of the body part. Let's see how these joint types look and function in real life. Reciprocally shaped mechanical articulations are found throughout the body, allowing for efficient movement and load distribution. For example, the ball and socket joint of the hip provides stability for weight bearing, while the hinge joint of the knee allows for powerful extension and flexion. These mechanical designs are not random, they are optimized for the specific functions required by each joint. By studying these articulations, we gain insight into how the body maintains both flexibility and stability during complex movements. Several factors can increase joint stability. A close back joint position where the bone surfaces are in maximum contact provides a solid foundation. Strong ligaments and muscle tendons crossing the joint add further support. When muscles on opposite sides of a joint contract simultaneously, they create tension that stabilizes the joint. Additionally, the absence of muscle fatigue is important. Tired muscles are less able to protect the joint from abnormal movement. All these elements work together to keep our joints safe and functional. Summary: joint stability is a complex interplay of bone structure, cartilage, ligaments, muscles, and movement patterns. Understanding how joints are categorized and what factors influence their stability can help us prevent injuries and improve performance. Whether you're an athlete, a healthcare professional, or simply interested in how your body works, knowing the basics of joint biomechanics is invaluable. Remember, maintaining joint health involves not just flexibility but also strength and proper movement habits. Thanks for joining us on this journey through the biomechanics of human joints.